Okay, now we are using our formulas SOHCAHTOA, trigonometry. And why are we using SOHCAHTOA? Because we're looking for the relationship between angles and length. That's the difference. Remember, Pythagorean theorem is just looking at right-angled triangles with length. When you're looking at a relationship between an angle and the lengths, that's when you need your SOHCAHTOA. So here is our right-angled triangle, drawn very poorly. Here's the right angle. This is our angle X that we're trying to find out here. We're given that this is 6.2 meters. We're given that this is 12.1 meters. And so we want to find out, what is this angle in here? This is our X. What is that angle? We can find out an angle using the length of these sides. Remember, always we label these sides according to their relationship with the angle. So if we look here, this side is opposite your angle. This side is next to or adjacent. So if we have opposite and we have adjacent, then we know, we look in our formulas and we know we need tan because it's opposite and adjacent. That's what we have. So we're going to use tan. So now we say tan of X is our angle, equals opposite, which is 6.2 over 12.1. So I pop that into my calculator and I get 0.512, blah, 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 it keeps going, 39. And really, if I keep this in my calculator right now, that's the best thing to do because we want exactly a number exact as we can. Remember, we have tan X. We want X by itself. And remember, when we want to isolate X, we take the inverse of what is over. So we take the inverse of what is over here, which is our tan. How do we do tan inverse of tan? That means X is going to be our answer, which is this, times the inverse of tan. So I'm going to pop that in my calculator now. And after I popped that in, I get X is 27, and it says to one decimal place, decimal, and it's 1/3, which rounds to 1. And don't forget your little sign, because that means it's an angle. So this is now our answer. X is equal to 27.1.